Yes, guys, I want you to, underneath your last lesson of work, rule off, write the new title and learning objective, pause the video so that you've got time to do that, and hit play when you're ready to keep watching. So, in the last few lessons, you've looked at exterior angles. You should know by now that exterior angles add up to 360. So, for example, in this triangle here, these three exterior angles add up to 360. And you should know that interior plus exterior add up to 180. Last lesson we looked at specifically how we go about figuring out questions with regular shapes. But this lesson we're going to turn our attention to interior angles, which is angles on the inside of polygons. Remember, polygon is a shape with 3 or more straight sides, but all the sides are straight. And we're going to start off with this triangle just here. Hopefully you remember that angles in a triangle add up to 180. So if you've forgotten that, it's very important that you know that. So write it down in purple pen. Also, we know that angles in a quadrilateral, like this one, what do these add up to? Hopefully you remember that angles in a quadrilateral, these add up to 360. Again, if you forgot that, make sure you've written it down, because today we're not just looking at triangles, we're not just looking at quadrilaterals, we're looking at the interior angles in any polygon, which means any shape with 3 or more sides where all the sides are straight. So what we're going to do is we're going to look for a pattern between the number of sides it has and its interior angles. If we spot this pattern, we'll be able to calculate the sum of the interior angles, which means all the interior angles added together in any polygon. So that's the plan for today. So what we're going to do is we're going to start off by looking just at this table here. Oops. So here we've got the shape. Let's do it in black. In this column, we're going to have number of sides. So at the moment, this shape here, the first one, this is a triangle, so it has 3 sides. In the final column, we're going to have the sum of interior angles. So that means the total of all the angles on the inside of the shape added together. And we know the angles in a triangle add up to 180 degrees. I'm going to leave this column here blank for the time being. Let's now look at question 2, at the shape 2. This is a quadrilateral, we've already said it. Quad means 4, which means quadrilaterals have 4 sides. And we already know the sum of the interior angles of a quadrilateral is 360. Now, I'm going to show you something on the quadrilateral. If I take this point here and I split the quadrilateral like that, how many triangles have I split it into? Hopefully you can see I've split it into 2 triangles. Taking each of the triangles individually, I know that those 3 angles add up to 180. I also know that these 3 angles here add up to 180. So 180 there, 180 there, that is where I get my 360 from. Now this idea of splitting up the quadrilateral into triangles is going to be very important for the pattern that we're trying to spot. I'm going to zoom out a little bit so you can see some of the other shapes we're going to look at here. The third shape we're looking at is a pentagon. Now all the shapes I've got here from the pentagon and hexagon and going downwards, they're regular, but they don't have to be. They wouldn't have to be for this pattern to exist. So a pentagon has 5 sides, and I'm telling you the sum of the interior angles of a pentagon is 540 degrees, which means if I added this one, this one, this one, this one, and this one, it would add up to 540. Now, have you spotted a pattern yet? Maybe you have. Maybe you haven't. Let's keep going. All the time you should be trying to find the pattern between the number of sides and the sum of the interior angles. This shape here, number 4, what shape is this? It's a hexagon, which means it's got 6 sides. Do you know the sum of the interior angles of a hexagon? It's unlikely you would, but fair play if you do. The sum of interior angles of a hexagon is 720 degrees, which means if you add up this one, this one, this one, this one, and this one, and this one, adds up to 720 degrees. You spotted the pattern yet? Let's keep going. See if you can spot it. Shape number 5 we're going to look at. This is a 1, 2, 3, 4, 5, 6, 7-sided shape. It's a heptagon. Can you guess what the sum of the interior angles of a heptagon is? It's 900 degrees. Surely you've spotted what's happening every time you add another side to the shape. Can you spot it yet? What's happening from here to here, from here to here? 6th shape we're going to look at. This is an octagon, 8 sides. You've guessed it, the sum of the interior angles of an octagon, 1080 degrees. Come on, surely you've spotted what's happening here. Final shape, a nonagon. Go on, what is that shape? What is that number? Well, hopefully you've spotted the pattern every time. Every time you add one side, you're adding 180 degrees to the sum of the interior angles. So it's going to be 1080 plus 180, which gives you 1260 degrees. Now this is all well and good, and all these sums that we've written here, the ones in the final column here, they are true of any 3-sided, 4-sided, 5-sided, 6-sided, 7-sided, 8-sided, 9-sided shape. It doesn't have to be regular. It's always the case that an octagon with 8 sides has a sum of interior angles of 1080 degrees. That's always true, even if the octagon looks like something like this. 1, 2, 3, 4, 5, 6, 7, 8. If I added up this one, 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 and this one, it would add up to 1080 degrees. Now this is all well and good. It's nice that we know these now, but it doesn't help us for finding the sum of the interior angles of a polygon with 1000 sides, because unless we're going to count plus 180, plus 180, plus 180, next one, and we do it 1000 times, we can't figure it out using this system. So now I'm going to introduce the 3rd column here, and I'm going to call this column number of triangles. Obviously with the triangle, I'm going to rub off these numbers. I think they're a bit confusing. I was just ordering them. Number of triangles in the first one, there's 1 triangle. And we said for the second one, for the quadrilateral, there's 2 triangles. What about for the 5th shape, for the pentagon? How many triangles can you fit in there where all the lines come from one point like this? Well, hopefully you can see you got 1, 2, 3. There's 1 triangle, there's another triangle, and there's another triangle. Each of those triangles has how many degrees? I'll let you think about that. What about the hexagon? How many triangles can you fit in the hexagon from this point? You've got 1, 2, 3, 4. You've got 4 triangles you can fit in here. 1, 2, 3 angles there. That's 1 triangle's angles. There's another one. There's another one. There's another one. Each of those triangles has how many degrees? 4 lots of 180. For the Pentagon, it was 3 triangles, 3 lots of 180. For the quadrilateral, it was 2 triangles, which is 2 lots of 180. Can you spot the pattern? What about the heptagon? 1, 2, 3, 4, 3, 4, 5. 5 triangles. Each one has 180 degrees inside. 5 times 180 is 900. Can you spot the pattern yet? 1, 2, 3, 4, 5, 6. 6 triangles, each with 180. 6 lots of 180 is 1080, and I'm sure you can guess the last one. We can fit 7 triangles in. Each of the triangles has 180 degrees. 7 lots of 180 is 1260. Now what we can do is we can create a formula here. The number of sides I'm going to call n. N for number of sides. The number of triangles, can you spot how we go from the number of sides to the number of triangles? What is happening every time? Can you spot it? 3 to 1, we're taking away 2. 4 to 2, we're taking away 2. 5 to 3, take away 2. Every time, the number of sides minus 2 gives us the number of triangles. So we're going to call that n minus 2. And for every triangle that we have to times it by 180 to find the sum of the interior angles. And so what we have here is n minus 2, which is the number of triangles, times by 180, because there's 180 degrees in each triangle, gives us the sum of interior angles for any polygon. Which means if we had a 1000 sided shape, that would be, n would be 1000, so the number of triangles would be 1000 minus 2. There's 180 degrees in each of those triangles, so you times 998 times 1000 times 180. 998 is the number of triangles times 180, and that would give you the sum of interior angles in a 1000 sided shape. This formula, this is a very important formula, guys. We're going to be using it, well, sometimes. It's not as important as the box method, but it's still important. So make sure you've written down the formula. If you've written down a lovely table to show exactly what's going on, then excellent. But I'm not too concerned if you haven't written down the table. This was just to help you see where the formula came from. Key thing is, the sum of interior angles of any polygon is equal to the number of triangles you can make within it times 180. Or n minus 2 times 180 is the sum of interior angles. Now let's just do an example. For 8, if we have an 8-sided shape, that means n is 8. We've got 8 sides, n sides, 8 sides. N minus 2 is going to be 8 minus 2. That gives you the number of triangles, and then we times it by 180. So you can fit 6 triangles in an 8-sided shape. You can see that over here. Times by 180. When you do that, you get 1080, which confirms what we have over here. There's a lot on the screen, there's a lot going on right now, so I'm going to get rid of it all. Right, let's have a go at calculating or figuring out this example here. So this is example 1. Pause the video and have a go at answering this. So the sum of interior angles of any polygon is equal to the number of sides, call it n, minus 2, which gives us the number of triangles in that shape, times 180. So in this case, n is equal to 1, 2, 3. I won't do that because that implies they're the same. 1, 2, 3, 4, 5 sides. So n equals 5. So all I'm going to do is substitute, which means replace with brackets, the 5 for the n for the 5, and I'm going to calculate. 5 minus 2 is 3 times 180. 3 times 180 is 540. So the sum of the interior angles of this shape is 540 degrees. Now you may be thinking, obviously I knew that, sir, we'd already done it earlier in the video, and it's true. I'd already written down the sum of the interior angles of a pentagon is 540. But now you can see how we've calculated it. You need to remember this one, guys. You need to remember that that is the sum of the interior angles of any polygon. Very important. If I haven't made it clear, this is the whole lesson. This is the sum of interior angles of any polygon. Make sure you've written that down if you haven't already. And we'll do the next example. What is the sum of interior angles in this shape? Pause the video and have a go on your own. Press play when you're ready for me to go through it. All right, so this one is 1, let's do a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10-sided shape, which means n equals 10. The number of sides is 10. The formula for the sum of interior angles is n minus 2 times 180 equals the sum of interior angles. So I'm going to replace my n for 10. Substitution, replace with brackets. And when I put in dot 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 here, I just mean that the sum of the interior angles. Just can't be bothered to write out of interior angles every time. 10 minus 2, one step at a time, copy it down. 8 times 180 is 1,440. So the sum of the interior angles of this shape is 1,440 degrees. Make sure you've marked it in purple pen, anything you need to. And then make sure you re-show my homework so you can see clearly which Hexagon math task I want you to do. Thanks for watching. Bye.